You've just ordered food and you're staring at this page. It says preparing your order, and it has said that for 4 minutes. So you do what everybody does. You pull down to refresh. Nothing. Again, still nothing. And then, while you're sitting there doing absolutely nothing, a message from the driver appears at the bottom of the same screen. You didn't refresh. You didn't tap anything. So, how did that message get in? Two parts of one page, and they're getting their updates in completely different ways. Here's the thing that makes this interesting. Ordinary HTTP has a rule that sounds almost too simple. The browser sends a request, the server sends a response. The browser always goes first. Think of phoning the restaurant to ask if your food is ready. You call them, they answer. That call ends. If you want another update, you have to call again. Which leaves us with a real problem. If the browser has to ask for everything, how does anything ever arrive on its own? There are 5 useful ways browsers handle this problem. By the end, that chat message won't be mysterious. Before we go through them, I want to give you something to hold on to. Every one of these 5 answers the same 3 questions, and those answers give you the map. 1. Who starts it? 2. Does the channel stay open after the data arrives? And 3. Who can send the next update without a new request? Keep those 3 in mind, and none of this is hard. Miss them and it turns into 5 names you have to memorize. And we'll keep rebuilding the same page as we go, changing only how it talks to the server. The first answer is simply to automate what you just did. Instead of making you refresh, the page asks for you. Every few seconds, it quietly sends the same question. Any update? Any update? Any update? This is called polling, and it's you phoning the restaurant every 2 minutes. Well, however often the page was told to. Most of those calls, nothing has happened. They pick up, they say, no change, you hang up. So, our 3 questions. The browser starts it every single time. The channel doesn't stay open. Each answer finishes the exchange. And nobody can send you anything until the page asks again. It works, and it's the simplest thing you can possibly build. But notice what it costs. Most of those calls found nothing, and when the news finally does arrive, you hear about it on the next tick of the timer, rather than when it happened. So somebody asked an obvious question. What if the restaurant just didn't hang up? That's long polling, and it's a small change with a big effect. The page asks the same question, but this time, the server doesn't answer straight away. It holds the request open. It just waits quietly until something actually happens. The moment your food is picked up, the answer comes back. So the page can update as soon as the held response returns, instead of waiting for the next timer tick. Then that response is finished. So the page immediately opens another one and waits again. The 3 questions. The browser still starts it. The channel still doesn't stay open. The response ends when the news arrives, or when something in the middle gets bored and times it out. And the server can finish that one pending answer, but after that, the browser has to ask again. That timeout is the part people forget. Networks, proxies, and servers all have their own patience. And when it runs out, that request ends and the page starts over. We've removed the timer wait, but we're still trading one question for one answer, over and over. Which raises the next idea. What if the answer never had to end? This is a natural fit for something like order status. The page asks once. The server starts answering and then simply doesn't stop. It sends the first update and leaves the response open. A while later, it writes the next one down the same response. Picked up. On the way. 2 minutes away. One question and an answer that keeps going. This is called server sent events, and it's the restaurant saying, stay on the line. I'll keep you posted. The 3 questions. The browser starts it. once. The channel does stay open, and the server can send the next update whenever it likes without you asking again. There's a lovely detail here. If the connection drops, the browser reconnects on its own, and if those updates have IDs, it tells the server the last ID it saw. You don't write that part. Be careful about what that does and doesn't give you, though. The browser says where it got to. Whether the server can actually resend what you missed is something you have to build. It's a bookmark, not a guarantee. So our order page is finally behaving. But this stream only solves updates traveling one way. Chat needs something different because both sides have to speak. This is the one you've probably heard of: WebSockets. In the classic handshake, it starts life as an ordinary HTTP request. The browser sends one, with a header that politely asks to change the arrangement entirely. If the server agrees, it answers with a status code you'll rarely see anywhere else. And from that moment, the connection stops behaving like the web and starts behaving like a phone line that nobody hangs up. You type to the driver types back, and neither of you is making a new request each time. Our three questions, and here's where the last answer finally changes. The browser still opens it. That never stops being true. The channel stays open. And either side can send the next message at any moment without being asked. That last one is the whole difference. Your order status only ever needed the server to talk. Chat needs both of you. There's one more, and it exists because of a problem you can only see when you push things hard. Watch the driver moving on the map. That position is updating constantly, several times a second. The classic TCP backed WebSocket we just described sends everything down one ordered line. If one small piece goes missing, everything behind it has to wait while that piece is sent again, including messages that arrived perfectly and have nothing to do with it. For ordinary chat, that's usually fine. For a map position, it's the wrong trade. By the time the missing update arrives, it's already out of date. You'd rather have the newest position than a complete history. WebTransport over HTTP3 gives us another option. It gives you separate streams, so a loss affecting one doesn't automatically make unrelated streams wait. Plus updates, it doesn't promise to redeliver. Our three questions give the same answers as WebSockets. The browser opens it, the channel stays open. Either side can send. So this time, the difference is underneath. Two honest notes. This is genuinely new. Support across current major browsers, only completed in March 2026. And some implementations can fall back to HTTP2 over TCP, where those disposable update benefits disappear. So the part you actually came for. Which one do you reach for? If a few seconds of delay is fine, polling may be all you need. It's the least machinery for the job. If the timer delay is the problem, hold the request open and reopen it after every answer. If updates only need to travel from server to browser, order status, prices, progress, notifications, server sent events keep one response open, and the browser handles reconnecting. If both sides need to send whenever they want, use a WebSocket. And if independent streams or updates you'd rather drop than resend genuinely matter to you, that's when WebTransport over HTTP3 starts earning its complexity. One trap before we finish, because it catches people who understand all of this perfectly. These aren't rival technologies where one wins. Look at the page we've ended up with. The order status and the driver chat are using different mechanisms on the same screen at the same time. That's normal and it's correct. A bigger mistake is picking one for the whole application and then fighting it for the next 2 years. Ask the three questions per feature, not per project. So that message that appeared while you were sitting there doing nothing. Now you know exactly what happened. A channel was already open. The server had something to say, And it said it. Every one of these has another layer underneath it. That handshake we passed over in about 30 seconds is a whole video on its own, and it's the next one.